Hello, my statisticians. This is Professor Sampson from PS I Love Math, back with another statistical banger. Today, we're going to start talking about introduction to probability. And as you can see, we have all our games here because all games are based on probability. So we're going to get this started. So don't forget to like, comment, and subscribe. And I'm out of here. Hello, and we're here at my share screen back with another statistical banger. So we're going to go into chapter 4. Chapter 4 is about probability. We're going to talk about probability this chapter. No matter where you are, whether you're my student or a YouTube student, probability is interesting, is where it's at. So the first part of this section is going to be titled the basis of it, using definitions, lots of definitions for all these terms that you're going to need when we're doing this whole probability stuff. So let's get ready to get to it and let's do it and all that other good stuff. So let's start with this probability stuff. All right. So the first thing we're going to talk about is what is a probability experiment? All right. A probability experiment is a trial. A probability experiment is any process with the result determined by chance. A probability experiment is any process that we use with a result that's determined by chance. So for example, what's determined by chance? Flipping a coin. Well, flipping a coin, tossing a die. So probability experiment is anything that results determined by chance. And so then what do you have from that probability experiment? Well, I guess you have an outcome, right? So you're going to have an outcome. Well, what the heck is the outcome? Well, the outcome is each individual result that is determined at random. So is every individual result.
90% of the time, I have no idea what the fuck I'm talking about.
Every individual result that is determined at random. Every individual result that is determined at random. So what's the next thing we want to talk about? Sample size, the set of all possible outcomes for a given probability experiment.
I have no idea what you're talking about.
You ain't hear me. Sample size, the set of all possible outcomes for a given probability experiment. So any possible outcome of your probability experiment. So let's recap. So your probability experiment is a trial. Your sample size is all those possible ways that you can happen. So for example, in my coin flipping, what are my possible outcomes? Head or tail? So my sample space is heads or tails. Heads or tails. Heads or tails.
Oh my God!
Okay. So my sample space is heads or tails because that's my experiment, and my sample size is heads or tails. That's all the possible outcomes. It just happens to be 2. If you have a die, what is your sample size? 1, 2, 3, 4, 5, 6. So in a die, 1, 2, 3, 4, 5, 6. That's your sample size because those are all possible outcomes. Well, if we move from possible outcomes, are we always looking for all possible outcomes? No, we're really not looking for all possible outcomes. Think about it. What are we usually looking for? So when you're at a ball game, are they looking for all possible outcomes when they toss the coin? No, they're not looking for all possible outcomes. They're looking for an event. They're looking for a subset of the outcome. What's the subset of the outcome? The subset is one of the possibilities. So if my possibility is head or tail is my sample size is head or tail, an event is head or tail. That's a subset of your possible outcome. So we have a probability experiment. We're about to do a trial. We about to get ourselves a die and start shooting crap. Anyway, so we about to get ourselves a trial, right? We're going to get ourselves a trial. And what's our trial? We got a die, all right? Every individual result that is determined at random is an outcome. So I got how many on that die? I got 6 outcomes. All set of those outcomes are our sample space. 1, 2, 3, 4, 5, 6 will be our sample space. An event from that outcome, an event from that sample space would be 6 or 3 or 2. If I'm rolling my die one time, then my event 3 or 2 or whatever I'm looking for. So you know we're going to a place where I have to say what we're looking for because I can't keep saying or this or that. That's how we start off our probability. So that's how we start off probability. So let's move into, there are 3 types of probability. What are the 3 types of probability? The first one that we're going to discuss is experimental probability. Experimental probability is that you actually did something. There was actual experiment performed. Now, you don't actually have to do the experiment, but there had to be an experiment that was performed by somebody. And how do we abbreviate that? How do we write it? The probability, parenthesis, of an event is equal to F over N, where F is the frequency and N, back to that N, is the total number of times the experiment is performed. F is the frequency and N is the total number of times the experiment is performed. How many times did you throw that coin up in the air? The probability of E is the probability of the specific event that you're looking for. So, for example, if I'm throwing a coin, I'm looking for a specific event. I'm looking for either heads or tails. I would say the probability of getting a head. The E is my specific event, which I'm talking about getting a head. And then I toss my coin, let's say 10 times. 10 times would be the total number of times. And let's say I got 3 heads when I tossed it 10 times. Or let's say your friend tossed it and they got it 3 times. So you see how that works. Experimental probability, somebody has actually done an experiment. The other type, the second type of probability is classical probability, or sometimes you'll see it called theoretical probability. So I may change these words on an exam or something like that, but you'll know that they're the same thing. Classical probability or theoretical probability is your second type of probability. Well, what is that? Classical, think of classical music. Classical probability, no experiment was performed. It's just the actual probability using the number of outcomes in the event over the number in the sample space. I'm going to write the formula down and then we'll discuss it. So I still have my probability of whatever my event is going to be. Classical probability, the formula is P of E, the probability of whatever your event is. E stands for event, whatever that event might be. The number of outcomes in the event over the number of outcomes in the sample space. What does that mean? That means the outcomes in the event. For example, classical probability means that I did not actually do an experiment. I just know the number. The probability of getting a head in the classical probability is what? When I throw up my thing, what's the number of outcomes in that event? 1 head out of what's the outcome in the sample space? Let's go back to our brain up at the top. The sample space is the number of possible outcomes is head or tail, so that's 2. Classical probability or theoretical probability, that's why I like theoretical probability. Theoretical probability is a better name for it for you to understand what it is. Theoretical probability is in theory. In theory, this would happen. In theory, this would happen. Experiment is I actually did it and this is what happened. 2 different things. Think about it. In theory, you should get 1 out of every 2 heads, which if I use your classical probability or theoretical probability, you would have said if you threw a coin and you was looking for head and you threw it 10 times, in classical or theoretical theory, you would have what? 5 of those 10 be head. But you actually performed the experiment and you only got 3 of those 10, and 3 of those, I don't even know shit. You actually got 3 of those flips to be head. So that's the difference. Theoretical is the theory, where experiment is I actually did it. Another example, boys and girls. You would say the probability of having a girl is 1 out of 2 possibilities. All right, we're not talking about this other scientific stuff.
Oh my God!
1 out of 2 possibilities. However, if you go to any hospital, go up the street to the hospital or the hospital closest you, and you start counting babies and you're looking for girls, you might get 7 out of 25. The thing is, well, how is it that we say it's 1/2? How, if this is the case, do we say that tossing a coin is 1/2, when in theory it should be 1/2. But when we performed the experiment, it wasn't 1/2. What's going on here, Professor Sampson? Stop making up. That means that we want to look at the law of large numbers. The law of large numbers. The law of large numbers states that the greater the number of trials, the closer the experimental probability gets to the theoretical probability. What does that mean? That means I only threw my coin 10 times, so it might be off. But if I threw my coin 5 million times, it will get closer and closer to my classical theoretical probability, the probability that should be happening. So the more trials that I do, the closer it will get to that theoretical probability. So individual probabilities don't matter on that small scale. As we do more and more trials, you'll see that our numbers will become closer and closer together. So if I have 30 of you in class and you are throwing up and you're all throwing up coins, so I have 30 people rolling 10 times or 10 dice or throwing up 10 coins. That's 300 people. And with that being the case, more probable than not, we'll get closer than that 3 out of 10. So that's the law of large numbers, that the more we do the experiment, the closer that gap will close, and that experimental probability will approach that theoretical probability that you knew would always happen. So you may walk into a hospital and say 7 out of 25 babies are girls, but then you walk into all the hospitals in the state and you may see one where it's 17 out of 25. So they will start to even out and balance themselves and squeeze, right? All the way until they make it to closer and closer to that theoretic probability of 1/2. So the last type of probability, the third type of probability, is subjective probability. And I don't consider subjective probability a probability at all, but subjective probability is an educated guess regarding to the chance that an event will occur. The thing about this educated guess is that it can't be just done by somebody random. You go to your friend, you coughing and everything, and your friend like, oh my God, I think I got COVID.
Why are you crying?
And then you go, girl, bye. You don't have no COVID. You just got a regular cold. That's your educated guess. Don't mean nothing. An educated guess needs to be an educated guess by somebody who's educated in that field. Now, not that your friend's not educated. They're just not educated in the field. Now she goes to her doctor. Oh my God, I think I got COVID. And the doctor says, no, you don't. You just got a cold. That educated guess is subjective probability. It is an educated guess by someone in that field, in that area, educated to make that guess. It's not just anybody. So even if you come to me with all of my wealth of knowledge, right, and you say, Professor Sampson, what do you think about the weather? And I say, yo, it looks like it's about to rain. I need an umbrella. It's not an educated guess. It's just something that I'm saying. But if the weatherman then comes out and says, well, it's going to rain today, the cumulus clouds are, then their educated guess is regarded. Last one, you go to your friend and you say, yeah, statistics is hard. I'm about to fail. And your friend say, yeah, you about to fail. Then you come to me and you say, Professor Sampson, statistics is hard. I'm about to fail. And I say, yeah, you about to. Okay, all right. Now, anyway, you get the point. So educated guess regarding to a chance that event would happen that is done by somebody who's educated to make that guess. Those are all your definitions to your intro section to probability. I hope you got them down and I hope that you understand them. I will be back in my next video on the addition property. Don't forget to do what? Like, click, and most of all, subscribe. You know I'm trying to get to that 240. So like, comment, let me know what you think about this. And this is Professor Sampson from PS.
Just give it up.